All right, welcome to phase 2 of statistics. We'll look at some graphing of histograms, which are a little bit different than bar graphs, and we're going to start talking about measures of data, starting with measures of central tendency. So we are going to look at grouped data a little bit today, and you can actually group discrete or continuous variables, and we'll be doing both for you here a little bit later. In this particular problem, I've accumulated the height in inches of one of the groups of kids that I teach, and we are going to it wouldn't make it, first off, there's not a lot of repeaters in here, and so if I try to make a bar graph out of this, it would just be a bunch of short bars. So instead, we usually group our data so that we can get a better picture of it overall. So there's a couple things to keep in mind. You need to create intervals in which to place your data values. There's no set rule for figuring out your intervals. So a general rule of thumb is if you take the range of your data and divide it by 5, and then kind of play around with whatever that answer is to figure out how many bars you want to have. And then you create a frequency table from that, and you're basically just counting how many pieces of data fall in your particular intervals. So if we go back to our data, the max tallest person was 76 here, and the shortest person was 59. So if I subtract those and divide by 5, and again, there's no rhyme or reason for this, it's just kind of a starting point, I get 3.4. And I personally I like to have clean edges on my boundaries, if you will, so I wouldn't probably use 3.4. So I'm going to adjust this value to make it friendly. And again, this is how wide your intervals are going to be that you're going to collect data in. So I would either use 3, 3.5, or 4, and it actually doesn't matter which you use. The smaller this number happens to be, the more bars you're going to have. And so if you don't want a ton of bars, you want to make this number like a 4 instead of a 3. And if you did it with 5, that'd be great. And even if you did it with 2, you'd have a ton of bars, but you could do it. So we'll kind of show you both of those as we build our histogram. So initially here, I have decided to make my interval width 3, which I've highlighted right here. So that means over here from 58 to 60, so 58, 59, 60, that's why it's 3, and they all have to be the same width. Now, I checked Cognigy and an IB textbook, and it looks like this is a general trend for them, which is to not include the value in the bottom, but everything bigger than 58, but to include the upper value of 60. When we actually do this in our calculators, I'll show you that I think our calculator does it the other direction, meaning it includes the lower bound but not the upper bound. It does not matter, just depending whatever this is over here, you need to make sure you collect correctly. So if this is everything bigger than 58 up to and including 60, then if I'm going to build my frequency table from that, then that would be 59 would be the only one that would fit into that particular box, and this F is for frequency. So everything taller than 60 inches but up to and including 62 would include this 61 and this 62, so I put a 2 in here. And I guess I don't really know why I'm not doing that, but I'm not. So and you kind of build it's kind of painstaking, but that's how you would build it by hand. Again, this F is your frequency up here, and 3 is the distance from 58 to 60. Including the bound. So our table would end up looking like this. And you can see that each of these would represent a box on our histogram. So there would be quite a few of them. So if instead I decide to switch gears and do 4 as my interval, that means then I start at 58 and I don't include 58, and I go up to and do include 61-inch people. So that would now mean this first frequency would include the 59-inch person and the 61-inch person, so this would now become a 2. Then I start immediately at 61 and up to 64, including 64, so that's going to capture the 62, the two 63-inch people, the 63.6-inch person, and all of these 64-inch people, and then stop. So that's what I would count up and put into that table. So again, if I were to actually painstakingly do that by hand, this is what it would look like. And again, these are your intervals, and you could also do it with 5, which means I would come up here to 62, and it would mean you have fewer bars, and each bar is going to probably capture a few more people, and they'll look a little different, but it doesn't really matter which way you do it. So we're going to make the graph also, and again, it doesn't. I'll show you when I do your graphing calculator. So you can enter the data individually, or if it's already grouped, and I'm going to show you both and what happens, the difference between them, and where the difference is. So if here is our graphing calculator right here, and I'm going to scooch it over for you a little bit, and you might want to pause the video a few times because you're going to want to practice this. So to put data into your calculator, you hit the Stat button, which is right in the middle, and you're going to edit, and you hit edit. And so what I've done is over here in list 1, I have put in all of the data for the heights of you guys. So it goes all the way down. So if you need to take a pause, go back to the table page that had the table on it, unless I can bring this over here, and I will actually go, give me one moment, I'll go back so you can see the table. There's the data right there. I'm going to do it individually because that's often the way you're going to get it. So I'm going to shrink up my computer so you can kind of take a second and pause the video and put all this data in your calculator in the list 1. Okay, I'm assuming you've on pause and you've got your data in there. So if I want to graph a histogram for this, I would hit the second y equals button, and I'm going to come up here and make this a little bit bigger for you again so you can kind of see a little better. And you hit enter on the first plot, and you got to turn it on. So you got to go down. Mine's already on, and you got to click on. Then you got your choice of different graphs. This is the histogram, and my data is in list 1. So this is the difference right here when you're graphing from a single list of data, which is what I'm doing right now with all these heights. I put all those individually in list 1, and so my frequency is just the number 1. If you had a frequency table, and so it tracked how many of each value it was, then you would put your list 1 again is the values that they take, which would be the first column in your table, and your frequency list would be the second list, which is how often each one of those occurred. And then you would graph it from there. Now, when you're ready to go, you should hit the zoom, and there's a zoom stat button, so I always hit zoom 9, and there it is. There's my histogram. This is going to be a mess, so if I hit trace, it'll show me that I'm starting at 59 and going up to 61.8333 inches. I do not personally appreciate all those decimals, and officially you should probably write those numbers on the bottom. So I'm going to fix my histogram the same way we fixed the bin width of our values before. So I'm going to hit window, and I'm going to go, okay, 59 I think was the smallest person, but my max I'm just going to round up to 79. I want nice clean numbers. This is 2.833, so I'm going to make that a 3. We do not have to go into the negatives on this, and I'm going to make this, again, I can make it 9 or 10, just rounding everything to integers. And then you hit graph, and there's my very pretty histogram. And if I want to know what every single boundary is on the bottom, or all my intervals and the heights, I just hit trace, and I can walk through each bar, and then I can record these values at the bottom. But this is what I was talking about in terms of your calculator versus the way IB seems to do it. This is including 59 and up to, but not including 62. So the 62-inch person wouldn't fall in the first bar according to the histogram. It would fall in the second bar. So there you go. That is your quick tutorial on the graphing calculator. And voila, there's our graph. And again, yours doesn't look exactly like that if you don't fix it, but then you're going to, down here, you should be writing the values on each end of your bar, and these should have a scale, 1, 2, 3, 4, 5, and you should title your graph as well. All right, so you're going to pause the video and you're going to try it yourself. This is going to go in list 1, and this is going to go into list 2, and then when you get to the graphing page under frequency, that's what the F is, you're going to put in list 2. Pause, try it. All right, this is what my graph ended up looking like. Again, notice I changed my values here, and if I actually pull up my calculator, I can show you what I mean. If I go, I put mine into list 2 and 3 so I didn't have to mess anything up. But so here is this is my actual values over here, and this is the frequency, how often they occurred. And when I went to graph this, again, go up to stat plot, I would now come down to number 2, and there's the difference right there. The list of values is in list 2 and the frequency is in list 3, and then I would graph that thing. I probably should point out that this really should be a bar graph, not a histogram, because you can't have half of a sibling. So this is just using your data, which I thought you might find interesting, and including it with the calculator method. All right, so moving on. This is one thing IB loves to do. They love to talk about mid-interval values. The widths, it's lower boundary, upper interval boundary, and modal class. And we will be repeating some of these things before. The mid-interval value is literally the middle of the interval. So whatever your interval is, there's a number that falls in the middle. That's your mid-interval value. You're going to use it to calculate means and other thit so it is important to be able to calculate that one. The width for discrete, you just subtract. For continuous, I subtract and add 1 because it really is that entire, capturing the entire width of values because it's continuous. It doesn't stop at your actual value. It keeps going. And then lower interval is your lowest, upper is your largest for each particular interval. And the modal class, we're going to talk about mode a little bit later, that's your tallest bar. So if I look at our data, the mid-interval values would be what is right in the middle of this is 59.5. What is right in the middle of this? 62.5. Right in the middle of this, 65.5. My interval width is 4. And the lower boundary, since, I mean, you could go to whatever decimal you want, but I'm not including 58, so my low capturing a person of height here would be 58.1 inches up to 61 inches, and that's where I would stop with my upper boundary. And the modal class, which of these classes has the biggest group of individuals? There's 8 here, and that's your 61 to 64 inch class. All right, so here's the problem with group data. If you don't have the individual data and you only have the group data, in our particular table we had 8 people between 61 and 64 inches. I have no idea how tall those 8 people are other than that they're between those two values. They could all be 64 inches. They could all be 61.5 inches. Half of them could be 62. Half of them could be 63. I don't know. So since we don't know, we use the mid-interval value as the height of those 8 people. We're like averaging them out. So I would use consider those 8 people 62.5 inches tall. So I've now included a column for the mid-interval height right here, and again the frequency. So if I wanted to, for some reason, calculate the total height of the entire class, I would take this 59.5 times 2. I would take this 62.5 times 8, and this 65.5 times 5. And again, don't forget this summation just means I add those all up. So I would just add all of those values up, and that would give me the total height for the class. It would not be accurate because I'm using 59.5 for both of these people, and I actually know because I saw the data, neither one of them are 59.5 inches tall. And once I had that total, if I wanted the average for the class, I would divide that total. Again, that's IB does ask you to do this, where you multiply the mid-interval value times the frequency, because if you don't see the individual data, you can't tell exactly how tall these two people are. I would take that total and divide it by however many people are in the class, and that's just a sum of this frequency list. So again, this just means summation of my F list. So if I add all these up, it's 23 kids. And so if you take a notice, that would be, if I multiplied these, multiplied this, and added those all up, it'd be about 15, 18.5, divide by 23, and I get the class average height, which is 66.02. All right, pause it. You try it for the sibling one. All right, here's what you should have gotten for the sibling answers. Hopefully you unpaused it. Again, about 1.7 siblings. Again, this is not actually a continuous variable, so I'm kind of just using your data, cheating it a little bit, but just so you can kind of see how this process works. And now we are going to talk about the shape of our histogram, but we're going to video.